All right, thanks everyone. Nice to see you all. I hope we haven't faded too much in the afternoon. I could do with a cup of tea, but maybe after this. So yeah, great to be here. And let's talk about applying agents into some sort of real world domain. That's really what I want to explore with you in this talk. So, you know, a lot of the YouTube and example videos and things on Instagram that you can find are all about building agents to do more agents. You know, a lot of our agents are about building software, and the software we're building is for more agents, or else we're building Instagram posts and doing AI research to make Instagram posts. There's a lot of kind of, you know, self-reflective kind of work going on, and there's lots of really good nuggets of information in there, but a lot of them are not directly kind of translatable to actually doing sort of real work with agents. Not that, you know, coding, absolutely real work, but we code something to make something. We don't code for the sake of it. So really what I have done is started a company to try and bring the concept of agent money and exploration, which is, you know, something I've been working on within private mining companies for, you know, within big mining companies for a long time. But I could see that this really was an industry level shift. So that's what I'm here to talk about my experience so far. I only started my company a few months ago. I've been deep diving on a lot of Agentic work, have a development background, as well as applying that development into mining scenarios. But this is quite new. So what are the kind of challenges really around agents for real work? Really, it comes down to things like data. So data of the real world is often a measurement or an interpretation. It's not the actual, it's not necessarily the truth, right? So if we have a customer record, it probably is their real name. If we do a bank transaction, that should be the truth. But if you take a measurement of something that's underground from a drill core, or you take a remote sensing measurement, you know, you're only inferring through these proxies of measurement what's actually there. And so this makes a lot of the agentic work a lot more open, you know, AI in general in this space, just harder to kind of ground truth. So we're working with like multiple levels of uncertainty, you could say. It's also heavily dominated by STEM people, you know, technical experts do this work. And so when we're trying to bring agents in, we're going to have to build a lot of trust, because if someone is used to making the calculation and your agent does it wrong once, it's over. Okay, so we really need to make sure this is right. Obviously with banking or something, you need the agent to be correct as well. But there is a different level of people really with their hands in the data. And at the end of the day, if we're doing mineral exploration, we want to spend our money on drilling into the ground. We still need to actually take more measurements, and that's very capitally intensive. We're going to spend a lot of money doing that. So the more that we can spend the money in the right place, the better. So how can we use agents in this kind of way? Now, we're talking a lot about agents today. For me, you know, we say agent as though we all know what it means, but it doesn't really mean any one particular thing. And really, even since submitting this talk, so many things have changed that I've kind of been restructuring even the way I talk about agents. And so some of what I wanted to go through was kind of what are those different ways of using agentic capabilities, and how can we use them in developing new products and solutions. So, you know, local harness, I'm talking Claude Code, Cursor, Codex, you know, there's other open source ones there. It's super powerful. And even from February to now, huge game changing, right? So I've certainly always been using a local harness to do development of the agentic capabilities. But now, you know, I'm starting to think, can I just release something where the person just uses Claude Code? You know, I mean, am I going to build a better harness than this? It's super powerful. But it is local, and therefore it's going to have challenges in terms of compute, in terms of scaling, in terms of control, in terms of getting big data to you. You know, there's lots of downsides as well as upsides. We're seeing a lot of agentic workflows really being called agents, but I would say, you know, if you're kind of quite prescriptive about what an agent's going to do, it's not really making its own decision. It is still doing agent-based actions, but you're not, you know, a lot of the time we don't want to just say go and do whatever you want to achieve this goal. We really do actually want certain steps to happen. And so there's lots of good kind of platforms in this space, but they're still quite hard sometimes to get to your data or to get the compute that you need. You know, processing an invoice is quite different to doing a giant hyperspectral survey where you need like gigabytes or terabytes of data. I've kind of called out another angle, which I'm quite interested in, and there'll be a bit in this talk, which is really the kind of chat-driven agent, which isn't local. So it's got more sort of cloud resources, but it's not really just code in the cloud. It's sort of somewhere in between. Like it's got more power than an agentic workflow, but you're still controlling it, but it's still got guardrails. And for me, the real key here, which I'm sort of excited to show a bit later, is really around visualization. So there was a talk earlier, and I think there's one right now, which I'm sad to miss, but around this sort of MCP apps idea, which I've got some alternate kind of ways to look at this as well. How do you start to interact with an agent, but not just through text, right? So a lot of what we do in mining is spatial, it's visual. We've got to look at data, we want to look at graphs, and not just pure BI. So there's some good solutions in this space from some of the platforms that people in this room come from. Really great for BI, you can just scatter plot or something, but it's not really up to scratch for geological data interpretation. And then the future, of course, big orchestrated agent teams, agents having all sorts of different levels of responsibility, super exciting, probably a little bit too far in the future. So I'm going to just walk it back a little bit today. I'm also interested in how do we bring this to market, right? So I've started a company. How do we make money out of creating agents? I don't yet have the answer. If anybody knows, please come to me afterwards. Because we're trading off between that, you know, that tension between the local capability that people know what they want to do, they can give them some skills, they're getting this amazing outcome, but can you control the code? You know, they can still go off and do all sorts of crazy stuff, and how can you sell that? Then there's also obviously like building something in the cloud, which is also something I'm doing, but it's quite expensive. It requires a lot more engineering. You want to put the guardrails in, but then maybe people want to do more with your platform and they're like, it doesn't do enough for me. So, you know, there is a trade-off here. I don't know what the answer is, but it's interesting to kind of walk both sides of the road here. So it's really going to be important that we look for people who can build AI for technical domains. So, you know, even if you don't have experience in a technical domain, think about how you could meet up with people who are in a technical domain who can't build the AI. And we increasingly need these cross-functional teams and a few cross-functional individuals who can kind of straddle both sides of the aisle. And that's how we're going to get real value out of these systems, because I see a lot of things from people online. They're like, oh, I've got all this, I'm building this agent, but like I've run out of ideas. And there's other people like, I'm doing all this work by hand in Excel. Like I need something to help me. So, you know, I'm really hoping, you know, in the next couple of years, this is really where things change, because we need people who can do the AI engineering, the harnessing, the, you know, the context, the security measures, all that kind of stuff. But if you don't really know what the result's supposed to look like, it's very hard to build a technical solution. And then on the other side, you've got geologists who know what they want, but and while they can buy products and stuff, it's not really going to scale. It's not going to give them the reliability. I've been working in this space outside of AI agents for a long time. We call it Valley of Death in technical readiness levels. It's where you go, you know, from a working prototype, but you really can't, how do you get to production? How do you solve all those edge cases, all the engineering work? So it is a challenge, but I think Agentic AI is finally the technology that's going to help get us through there faster, because it really does have these capabilities that we don't have to hard code in every little edge case. It's finally able to do a few things itself on the fly, which is super exciting. But yeah, simple, naive systems aren't going to cut it when we're really moving into deep technical domains. So the approach that I've really been landing on is around using a software engineering approach to build skills, basically. I mean, skills is kind of where it's landed. I've been building skills for a while, but it wasn't until maybe a month or so ago that it really landed for me, where I had built enough skills that I was seeing this compounding effect. So using a Claude Code or a Codex, I'm able to generate really domain-specific skills. So sometimes this will be new code, but sometimes it might just be calling a piece of code or a library that already exists. There's plenty of open source and closed source mining exploration software out there, but it hasn't really been agent ready. So once you wrap these into skills, you start to get these primitives, right? And so again, if you build a Python library, you're going to build lots of primitives, and over time it grows and it becomes more capable. Skills, I kind of see the same way. We build these skills to do small things well, and then we compose them into bigger workflows. And then we can either create, reasonably deterministic workflows. Like I always want to take this data, run it through QA, calculate these things. The agents and the skills are still more flexible than an old school kind of QA script might be, because an old school script might fall over as soon as it sees an edge case it's not programmed for, whereas an agent can adapt on the fly. But we still might want it quite rigid. But then we can also start to have that, use that locally to then push the boundary of where we want to go next in a more uncontrolled kind of way. And when you're working in mining and exploration geology, every system is a natural, organic thing that the earth has created. They're all different, right? And every measurement set is different. So there's a lot of variety that we really do need to account for. So, we can only do so much in terms of workflows. My other perception is that actually in these kind of technical domains, as I said, there's a lot of people whose whole job it is to crunch the data through Excel or through one of the custom pieces of software. They're not ready for an agent to come in and do that for them. Okay, so that's okay. And I kind of don't blame them, because really until even a couple months ago, there was still a lot of unreliable outcomes. Still, people still really talk about hallucinations. I don't know where maybe I just only do specific things, but I don't see too many hallucinations in what I've been creating. At the same time, I can see how it only has to happen once and you really lose trust, right? So it's our job as builders to kind of work around all these concerns. And I think building specific skills that we can get into people's hands where they can start to feel, experience, same with what we're doing with coding, right? Like you're using the coding harnesses and you're seeing them get better and better and you trust them more and you just click yes, go ahead, or live dangerously. We want the geologists and mining engineers to start to be like dangerously skip permissions, but with the full audit trail, right? So at my company, we're building lots of tools and agent skills. This is how we learn and can try and stay one step ahead. I'm building both open source and proprietary capabilities. I think that there needs to be more open source, reliable tools for the industry that are kind of leveled up. So there's lots of really good ancient tooling that's based on old Fortran code that's been moved to Python, and it's well tested, but it often requires big, heavy GDAL environments, whereas a lot of these calculations are not that. They don't really need that full install. So I'm trying to build a kind of more lightweight open source stuff. So I've called that baselode, and it also contains a lot of visualizations, which is something I'm going to share. On top of that, I've built a couple skills repositories, so you're welcome to check them out. I've also started trying to do a Substack where I kind of go into a bit of detail about how to use the skills, again, to kind of explain to people. And 100% vibe coded, I'm not going to deny that, but they work and they are composable examples of how you can build up technical capability when you're doing calculations and things like that. I'm also releasing an app and a bunch of agent work, all still kind of in development at the moment. So I'm calling it worked example. I'm not showing too much code, but we'll just go through a kind of run, and I just want to show how you can get started with something. I will call it out. We'll probably not be able to discover gold at the end of this talk, but if you don't start here, you're definitely not going to get there. So pay attention. As I said, it compounds over time, right? You've got to build the foundation. So we're going to get some data, I'm going to run some QA/QC, I'm going to do some typical calculations like an intercept or a desurvey, visualize, interpret, and model. And I want to talk about this kind of it's a bit of a workflow. Along the way, they'll, the user will want to look at the quality of the data and the changes. But I want to talk about it through three kind of approaches, as I said earlier. So what are the advantages of doing this sort of stuff in Claude Code or Codex? What are the powers of doing it locally? What has my experience been setting up an agent workflow? And what does it look like if we actually start to put it in a chat? So in Claude Code or Codex, I'm using all my open source libraries. You can kind of tell it what to do. You can be quite interactive. You can tell it to make up its own plan. You can tell it a plan. Obviously, you've got full control here. And what I really love about using the data interrogation skills with Claude Code is that when it comes back to you with like, here's all the different errors that I found in the data, is you can deep dive each one in a conversational way. You can get it to summarize for you in different scenarios. If we run it through agent workflow, I've been experimenting just with some basic harnesses, just using some of the Python libraries that exist to wrap the models and just kind of building a reasonably prescriptive workflow, but that still calls skills. I, early on tried things like LangChain and all that. I don't think, correct me if I'm wrong, please, because again, you sort of try these things and they don't work and you dump them and you never know if they've changed them, but it's not really tied into the skills mentality. They've kind of got their own way of defining tools and things like that. And I started to find it very restrictive because I couldn't carry my capabilities across different harnesses, which I think is going to be important because again, they've all got their own role to play in different scenarios. And then I've built a chat into my app that lives inside the Fast API backend of the app. Again, it uses some sort of OpenAI libraries. It doesn't really call skills. It's sort of using more tools that are in my code. It's probably due architectural review. I am very interested in anyone that might have a better idea of how to do it. I really kind of want to put Claude Code in the cloud, but then that's going to have probably too much power in some places and then also maybe not be able to do things that I want to do. So again, if I just think that there's no right answers at this point in time. We're kind of figuring it out as we go, and even some of these decisions are months old now. And to be honest, maybe just throw it out and start again. But we'll stick to some foundations. So absolutely working in technical domain, work with the data schema. So Claude Code, for example, really good at inferring schema on the fly, which is really useful in geology. You can often have like lots of CSV files lying around with all different data in them, and you don't really know even what format they're in. Is this, what are the headings? Is it key value pairs? Is it flat file? There's so many different things, and you can figure it out on the fly, but it makes it very hard, obviously, to build reliable skills on top of it. So rather than letting the agent interpret it every run, obviously it's going to be good to build a schema. So if you do have certain data types that you're working with all the time, try and build something. I mean, as they say, the good thing about standards is there's many to choose from. Build your own, but then try and stay consistent within that. So I've built a number of skills as well to help with this so that the agent can try and get everything that's all random, at least into my schema. And then from then on, everything kind of needs to be assumed to be in that schema. In an agent workflow type environment, we've got a more controlled situation, so it's kind of already in the schema, and same with the chat. So this is really where it's more of a user-based experimental on their laptop trying to get the data all sorted. We then can do all sorts of interesting data manipulation. I won't bore you with the details necessarily of desurveying drill holes or finding significant intercepts, but suffice to say, if you download 4,000 drill holes and they've all got all these assays and lithology logging, you can at least now ask, go find me any significant, gold intercepts where it's more than this many grams per ton over this kind of meterage, right? Which doesn't sound like a terribly complicated calculation, but I have not seen any software where it's as easy as asking a question like that. Again, these things compound. This seems like a very simple example because it is, but over time, we're going to be able to ask more and more detailed, nuanced questions that under the hood, the agents are going to figure out all the details that combine together. So again, on your computer, you can just sort of say, show me problems, calculate this for me, and you can really have a good conversation. One of the limits I'm finding with the workflow is it's really a lot harder for the user to, to be able to interact with problems in the data. So while the agents can figure things out, if there's really some question like, oh, I think these two columns have been inverted, and you're trying to surface that to the user, that's going to be quite difficult if it's running in headless mode. And this is, again, just one of these things that in a data-rich environment is going to come up all the time. So I'm trying to think of like what's a good way to have these things run headless but still be able to surface the information. An agent chat, again, you're kind of user-driven. I think maybe more need to have like headless stuff that you can just jump in and answer questions. I don't know, it's still kind of evolving. The chat sort of sits somewhere in between. All right, so one of the things that I really wanted to talk a little bit about was really like looking at data. So if you caught the MCP apps talk earlier, they're sort of showing how we can move from beyond these walls of text into actual UI. Now they were showing an example of like, I don't know, booking.com or something. Like that doesn't really interest me that much. It's just more crap that you see on the internet. Anyway, what I actually want to look at is data on a map. I want to see data in a graph. And I don't just want to be stuck with the BI tools, a few histograms and things that you can get in the generic packages. I really want to see custom geological things. So what I've built, and I've open sourced these, probably need a designer to come in and just like clean them up a little bit, but primitives like maps, primitives like tables that you can download in any format you wish, primitives like full 3D scenes right in the chat. Also something called a strip log, which is a way of looking at geological data down a drill hole. So these are all primitives that all the software packages have. But what I've created instead is ones that you can generate on the fly in the chat. I'll just show a little video, which hopefully will run. Not the most polished, but what I'm using is a library called UI Assistant for my chat, and they have a thing called Tool UI, where you can create these primitives. You can already get weather widgets and different other little widgets, and I just use that to create the thing. So you can see, you can create maps, you can get tables, you can download. But what's kind of unique with what I've done, which I think is really necessary, is to be able to send from chat to your main working window. Okay, so if you are a geologist, you're not going to be flicking through the chat to see all your previous data. You need to bring it in to your main working area. So I'm still working on how to build this into sort of like a project concept, but where you can surface your data easily. You can show it on a map to see if it's even what you are after, or if you got it all wrong, it's got the name wrong. And then once you go from there, again, pull it up in the chat, but then send it to your more detailed space where in time, we build out functionality in the detailed space where you'll be able to click things and do things and send off other actions and stuff like that. So again, it's kind of early days, and there's only one drill hole in this, so I didn't do a very good example, but hopefully you're kind of getting the feel for really where we need to go next when it comes to any like real deep technical domain. Chat's not going to cut it, and just a few graphs is not going to cut it. We need to build up a lot more. So Tool UI I found really cool. There might be some other stuff coming out. Love to hear about it. The next, probably just got like two more things to touch on real quick, is actually where the real promise of domain-specific agents is going beyond the data processing. Now that we have the data, it's clean and it's in the right format, how do we actually use agents to do interpretation? And this is the bit that makes most geologists and mine planners and other people extremely uncomfortable, because surely an agent does not know anything, whereas they're trained on all of human knowledge. They actually know quite a lot, but you do need to set up the right context. So if you ask a random ChatGPT question about geology, you can get some pretty interesting results. You can ask about specific areas around the world, you can get quite detailed analysis back, but you're probably going to be looking at a certain area of ground a few kilometers across. So what one of the things I've been working on is how to structure the data for LLMs to better interpret. A lot of this data is spatial, so graphs and other kind of spatial representations of data is quite interesting. I'm kind of only just starting. I'm sure there's research out there, but yeah, really keen to get into this next level, which is actually starting to demonstrate unlocking that power within the LLMs to actually do interpretation, and multimodal as well. So, you know, we're always going to be looking at lots of different signatures, lots of different measurement things. In the old days, we have to create some big neural network with lots of layers, where you've got a geophysics layer, a geochem layer, you know, but there's no descriptive stuff, there's no relationship stuff that the algorithms couldn't flex. So I think there's a lot of potential here, which is super exciting. Still kind of still developing. I'm trying to build some eval suites around this to say, if you dumped in this data, what would a geologist think, and can we get the computer, you know, the AI to get to the same answer. The other next level that we want to take it to is really about using specialist tools. So I've just shown some basic things where you can kind of code it up yourself, but there is a whole suite of very expensive, very detailed, very well tested software out there. And so what I'm trying to show is how agent skills can call those as well. So you might mine your MapTech, your Leapfrog through a skill, or maybe if they eventually ever have an MCP server, you could call that. There's also some open source libraries. There's a really good RBF interpolation library that someone has created, and I'm trying to show how to wrap skills around that. There's heaps of great papers from universities with amazing algorithms that have never been fully leveraged by the industry, because it's just too hard to take like the random R code and like turn it into something that runs on your computer. But with the help of agents, we can get there. So I think it's super exciting. So agents are this connective tissue that's going to enable us to actually use a lot of what we've already got, but in a much more effective way. There's obviously also then the side where we've gone beyond what's possible on your computer. Like, you might need to launch an HPC to do some real number crunching. If you're going to do some geophysical inversions, it's not happening on this Mac Mini, right? Like, it's going to have to go out there. And so there's a whole bunch of engineering. It's not really agentic engineering, but it is still like, how do we let agents spin up big compute? Because again, that's going to be costly, and you know, all those sort of things. There are platforms that are probably helpful for that, but we're going to need a range of agent-friendly patterns and services where we can have guardrails. Like, if there was a SaaS product that your agent could go, give me a server, but if the agent asks 10 times, it cuts you off, you know, that would be great. Like, you don't have to build that. So yeah, I'm really looking forward to seeing where the ecosystem comes about. So takeaway, if you want to get into a technical domain, and that is really where the money is, let's face it, maybe, I'm hoping, you know, use real data, build skills, then build workflows, but then keep pushing ahead. Use a lot of interactive tools, and let's make that, you know, really the next horizon. If there's anyone with really cool UX ideas, I'd, you know, really love to hear about what we can do in that space. Obviously, we still need to build all the trust in both the agent and in the algorithms. And yeah, that's kind of everything there. Again, we can do a lot on our computer, but doing it locally is not going to change industries. We have to scale this up, but we have to figure out how to build the trust between what happens locally and the power with the control and the reliability that would happen in the cloud. And from here, there is a lot more things to be done in exploration and mining to actually go and find the gold. So yeah, if you're interested, come and have a chat with me. Otherwise, go and explore. Good luck.
Thank you.